Hey guys, today I wanted to show you one last type of confidence interval that we have, which is for the difference of two proportions, and also take a look at just some practice problems for the types of confidence intervals and how we would use the graphing calculator to assist us instead of having to do all these calculations by hand. So if you haven't already watched the previous video directly showing you how to use the calculator, you might want to watch that one first before we take a look at this one. But let's start with difference between two proportions today, which is very similar to what we talked about with the difference of two means, except obviously we're working with proportions or percentages right now. So here's a sample problem for us. It says a random sample of women and men who are aged 25 years or older were surveyed, and they were asked if they had completed 4 or more years of college. Results are listed below. Find a 95% confidence interval for the difference in college completion proportions between men and women in the population. So we see our data right here below, and we want to try to organize this. Remember that this p-hat value, which represents a sample proportion, that is made by dividing your x value by the sample size. And we have two of those here because we're comparing men to women. So we have an x value for women, and we have an n, a sample size for women, and the same thing for men. For the women, we have a sample size of 350, and of those 350, 100 of them completed 4 or more years of college. So our p-hat calculation is going to look like 100 divided by 350, and that will be our p-hat for the women. For the men, we have x over n, so xm and nm. We have 115 out of a sample size of 400. Now, again, I mentioned this with the difference of two means. You do not need to have samples that are identical in size to compare them. Okay, obviously 350 and 400 are different numbers. What is important is that they are independent of each other, and that it's not like if you're not in one category, you're in the other category. These two samples were obtained separately from one another. Okay. So this would be the p-hat value for the men. Now, we could get those decimals if we wanted to just by typing them in on the calculator, but the graphing calculator will take care of this for us. You can see this equation that we have right here. What we're doing is getting two of these measures of variation that's kind of a modified version of a single proportion confidence interval. You can see that you have a p-hat 1 and a p-hat 2, multiplying by its complement, dividing by its sample size, and then you're adding those together, taking the square root to get you that step size that you're going to the left and the right of the curve, or the center of the curve. And for a 95% confidence interval, we're doing two of them. The center of that curve is the difference. Okay, again, difference of two proportions. You're subtracting one from the other. Now, it doesn't matter which is which, but typically you go big minus small so that you have a positive confidence interval. We'll talk more about the conclusions in a couple minutes. You could do it small minus big, but then you're going to have negative numbers to deal with and interpret. It's just easier to go big minus small. So instead of doing that equation by hand, we're going to go with a calculator. And again, these commands are on the equation sheet that's linked at the top of this lesson page. So let's go over to the calculator here. And with our values, we're going to press stat and go over to tests. And we want a two proportion z interval. So on my calculator, and probably most of yours, that's letter B. Now we are going to type in the x and the n values. Now make sure you keep these organized. Because I want to do big minus small, I'm going to have the male values as x1. Okay, so I'm going to type in 115, and n is 400. For the females, that would be 100 for the X value and 350 for its sample size. We do want 95% confidence interval, so we just go down and hit enter, and you can see that confidence interval goes from negative to positive. Now these are very small numbers, that's okay, but look at the two p-hats, okay? The calculator does it for you. You can see those numbers are very close to each other, those percentages. So we had a 28.75% of males complete college within 4 more years, 28.57% of females complete college. So we are interested in the difference between these two proportions. So what that means is this interval crosses 0. Let's just go back to our other screen and we'll round this. Negative 0.06 to positive 0.07, we'll round that. Now the way we interpret this is because this interval crosses 0, okay, a difference of 0 means there's no difference between the two. Okay, so again, a difference of 0 means there's no difference between the two. And because that's part of our confidence interval, we do not have any, we have no indication that there is a significant difference between these two samples and these two populations. Because again, we're using our sample to say something about that population ultimately. Okay, let's say that this range had gone from, I don't know, positive 2% to positive 4%. Okay, then our interpretation would be we do have evidence that there is a difference, and that difference is going to be between 2 and 4. Okay, so the thing you are most interested in when you're looking at a difference of 2 proportions confidence interval or difference of 2 means, does that interval cross 0 or not? If it's crossing 0, okay, there's no difference between the two. If it's entirely above, or it could be entirely below if they're both negative numbers if you did small minus big, okay, then you do have a difference, and that difference is between those values. So let's shift gears and let's see how the calculator would help us with some of these other confidence intervals. Our next problem says a sample of 14 randomly selected commuters in Chicago showed the average of the commuting times is 33.2 minutes. So that 33.2 is our x bar. And we have a sample standard deviation of 8.3 minutes. We're asked to find a 95% confidence interval of the true average commute time. All right, so we're dealing with an average, so this is a mean, a single population mean. So we'll go to our calculator. You could use the equation, that's not that bad, but we'll go to our calculator, stat and tests, and for this we want number 7, which is a z interval. Now, there are 2 options for how you could enter this data. Okay, you could use the lists, raw data that you're entering into the lists, or you could just give it the values for mean and standard deviation, and that's what we have here. Okay, so in this problem, we're going to type in our standard deviation that we got. That was 8.3. They use the notation for a population standard deviation, sigma. Again, that is ideal, but a lot of times you don't have that population data. You're using the sample data instead. So a sample standard deviation of 8.3 is what we have. Our mean was 33.2. And our n value, our sample size, we were given 14 randomly selected commuters. Now, that's a pretty small sample size. In the coming weeks, we'll be talking about maybe using a different confidence interval, a different test rather than a z-test when we have a sample size that small. But for right now, we'll go with it. And hit enter, and there's our confidence interval. And we see 28.75% 28.8 to 37.5. So, confidence interval. What did I say? 27, 37. 37.5 minutes. So we are 95% confident that the true average commute time is between 28.8 and 37.5 minutes. You can see how this calculator greatly decreases the amount of time that you need for calculating these intervals. Let's take a look at our next one. A random sample of 205 college students was asked if they believe in haunted places, and 65 of those respondents said yes. Estimate the true proportion of college students who believe in the possibility of haunted places with a 95% confidence interval. Okay, so we're talking about a proportion here. There's no mention of mean, there's no mention of standard deviation. This is a single proportion confidence interval that we want to calculate. So again, we have our X value of 65 people saying yes, they believed this, and we have a sample size of 205, and together those are going to make our p-hat, which we don't really need to do by hand because the calculator will do that for us. So we'll go back to the calculator here. This is a one proportion Z interval. So stat tests, and this is letter A for a one proportion Z interval. Our X value is 65. Our N value is 205. 95% confidence interval. We see our p-hat, about 31.7% of people believe that a place can be haunted. And there's our confidence interval from about 25% to 38%. So p-hat we said was 31. And our confidence interval, sorry, got to check back here, 25 to 38. Okay. And you're free to either mark these as a percent like I did right there, or probably it's better to go with the decimal. We know that we can freely go back and forth between a decimal and a percentage. So our confidence interval for these proportions is going to be a decimal that represents a percent. We're 95% confident that the true proportion of people who believe that a place can be haunted is between 25 and 38%. All right, one more problem for us to take a look at. And this one says, randomly selected teenagers were asked to report the number of hours they slept on weeknights and on weekends. Use the data below and the graphing calculator to find a 95% confidence interval for the difference in the average number of hours slept between weekends and weekdays. So this one's a little bit different, and now that we're given the raw data, we are making a comparison between weekdays and weekends. So we have two different means. We don't know those. We need to find those. We have two different sample standard deviations. Again, we don't know those. We need to find those. To do that by hand is rather tedious, and we'd be using this equation right here. Same basic idea, but we're going two of those measures of variability above and below the center of the curve, which is the difference between those two averages. Let's go directly to the graphing calculator to have us enter these into L1 and L2. The calculator will find the mean, it will find the standard deviation for us, and it will use both of those to get the confidence interval. So let's go back here. This is a difference of two means. We're comparing two averages to each other. So we're going to go to tests, and we scroll down to number 9. This is a 2-sample z interval. And rather than tell the calculator what the mean, what the standard deviation, and what the sample size is, this problem gives us the raw data. So we need to go over to our input, and in our menu here, these are the values that we need to provide. Okay, so we will need to provide it with a standard deviation. We'll get that in a second. So we'll come back to this, and we need to first go to our lists. So let's press Stat and go to our lists L1 and L2. So in L1, we said we'll go with our first row of data, which was 8, 5.5, 7.5, 8. I see I messed up my 5.5. Continuing on. Those are all of the average sleep times for weekdays. And list 2, we'll go for the weekends. The order on these doesn't matter, but you do want to make sure that you match up the sample sizes. They don't need to be identical. Make sure that you have entered everything correctly. If you get an error or something different from what I get, go back and check your lists to make sure that you entered all the information correctly. All right, now that we have those entered, now we're going to go back and do our two sample z interval. And I forgot to have the calculator find the standard deviation for me. All right, so we have those values in the list. We need to go to calculate, and we need to go to 2var stats first. Okay. Just confirming our data is in L1 and L2. Okay. We need to get these 2 sample standard deviations. These are both samples, so we're looking at SX, okay, about 1.0, and scroll down. SY is about 2.7. Okay. So I should have mentioned that earlier, but we have S1 is 1.0 and S2 is 2.7, because we do need to tell the calculator this. This goes back to the whole thing where ideally you're using the population standard deviation if you have it. We don't, so we're using sample standard deviation. That's okay, but the calculator wants you to provide it with the population data if you do have that. All right, so the third time, this time we're actually going to do it. Go back here, we have 1.0 or just 1, 2.7 for our second standard deviation. And again, we're looking at L1 and L2. Calculator's going to find this, leave those frequencies at 1, 95% confidence interval, calculate, and here's our confidence interval. It also provides us with the means of those two. We see that the X bar 1 is 7, X bar 2 is 8.5625. So people are averaging more sleep on the weekends, but that second list did have a higher standard deviation, and we know that that's true because we had a lot more variability with that list. Somebody got 4 hours of sleep on a weekend while other people were getting 10, 12 hours of sleep. Everybody on the weekdays was a little bit more consistent. The range was smaller. Most people are getting about 6, 7, or 8 hours of sleep. But we have our confidence interval here. That's our final answer. Notice that this one does cross over 0. That's important when you're comparing two populations to each other. Okay, so we are at negative 3.6, we'll round that to, and positive 0.4. So our conclusions here or that we do not have evidence of a significant difference between these two averages. It crosses zero, and a difference of zero means there's no difference. Even though the two means, the two mean values, if we were to look at those, um, they do have some variation between them. Okay, we had said that the two means were 7 and 8.6. This one was 7, this one was 8.6, but that difference that we saw just by looking at those means was not enough to say that there was a difference in the entire population. Okay, I hope this helps, and I'm going to have you guys practice some problems, and hopefully you can use this information in the calculator to help you make more sense of this.